I'm standing before the belt diorama at the Beneski Museum of Natural History at Amherst College. It depicts Amherst some 190 million years ago. In this depiction, you can see mountains off to the east. Closer to us, you see a large lake. And even closer, you can see the dinosaur that's to my left. The environment depicted in the diorama was reconstructed from critical evidence preserved in sediments that were deposited in and around the Amherst area approximately 190 million years ago. These sediments, now sedimentary rocks, contain fossils and structures such as raindrop impressions, mud cracks, and ripples that attest to the past environmental conditions. In a moment, we're going to examine some of these structures. I stand at the entrance to the Hitchcock Ichnology collection at Amherst College. Ichnology is the study of tracks and traces. We will not find body fossils, we will not find skeletons here. What we will find is evidence of creatures, critters, that have moved around and been active in the past. We will see evidence of prior environments, whether it was raining, or if it was dry, or if there was water moving about. We'll see that evidence as captured in the sediment, and then lithified into the sedimentary rocks that we here have today. The sedimentary structure to my right are impressions that have been made in the mud, either by rain or by hail. These impressions would have been created by a rainstorm, a quick shower that came in at the end of the wet season, that last shower that kind of went into the mud. And as the mud dried out and hardened a bit, it would sit for 6 months until the next wet season would wash more mud down and fill in all the nooks and crannies and preserve what we see behind me. The sedimentary structure to my right are mud cracks or desiccation cracks. These are cracks that would have been occurring as the mud was beginning to dry. Again, at the end of the wet season, the mud dries out, and as it dries, it shrinks, and the substrate below the mud comes up through the cracks and kind of seeps out, and you can see these little seep areas here. This pattern is throughout the entire rock, again, indicative of the end of the wet season, the beginning of the dry season. The sedimentary structure to my right are ripple marks. Now, these ripple marks are ripples that were made in the muds. Now, again, you can imagine the water kind of moving back and forth and back and forth, and slowly but surely creating these little wave marks within the mud. But then again, the mud begins to dry out, the water evaporates away, and leaves behind the ripples that were formed at the edge of a lake. And these ripples sit for 6 months during the dry season, and it's the next wet season where they get buried by more mud and preserved until we see what we see today. Ripple marks. We have dinosaur tracks. We name them. We have what are called ichnospecies. That's ichno, of course, we're talking about the tracks and traces, and then a species. So we're naming that track or trace. We're actually not naming the dinosaur when we name them. The names we'll be using are names like Eubrontes, Anomepus, Otozome, and Grallator. Let's take a look. Well, what we're looking at here is a huge footprint. I'm going to put my hand here for scale. So now you get a kind of a sense of how big this footprint is. This is a footprint, an ichnospecies called Eubrontes. This Eubrontes track is probably close to 2 feet long. A 2-foot long track would extrapolate out to a dinosaur that might be 20 feet long. And this is just a huge animal. The ichnospecies is, again, the name of the track. Our best guess of the dinosaur that may have made this track is a dinosaur like a Dilophosaurus. What we're looking at is an otozome trackway. Otozome is the ichnospecies. Again, not the name of the actual dinosaur, but the name of the trackway. This particular ichnospecies, otozome, is noted for having 4 toes, and you can see the 4 toes 1, 2, 3, and 4. You can see the details of these, the whole foot. I mean, here you've got these incredible pads that make up the foot and the toes that come through here. This one's probably about close to 2 feet long, which again, extrapolated out would give you an animal close to 20 feet in length. If we take a closer look, and I'll try to bring this in real close here, you can see incredible detail in the pad of that foot. I'll hold right there. See the squiggly marks? We're looking at the impression of the skin. Such incredible detail. If we see one dinosaur footprint, it's a footprint. If we see a series of footprints that were probably made by the same animal based on their orientation, we see a trackway. We're going to take a look at one of those trackways now, so follow me. Here we go. So again, you can kind of see the first footprint, and then the second footprint, and the third footprint. Isn't this amazing? Kind of move up, move up, move up, move up, move up, and then finally just a little toe that's right there, and it disappears. We've just walked in the steps of a dinosaur from over 200 million years ago.